So today we are going to discuss this question. The question is determine the dimensional formula for conductivity. So we have to find the dimensional formula for conductivity. In previous video we have found the dimensional formula for power. Similarly, we are finding the dimensional formula for conductivity. So first we know that conductivity, that is conductivity which is represented by the letters, that is simple sigma, is equal to 1 by resistivity, okay, which is denoted by rho. So now we have to find an equation for resistivity rho. We know that resistance R is equal to rho L by A. This implies resistivity rho is equal to R A by L. Therefore, we get conductivity, that is sigma is equal to the reciprocal conductivity is reciprocal. So conductivity is the reciprocal of resistivity. So we get conductivity is equal to L by Ra. Okay. Now we are substituting for this R here. So that is resistance. So we know that voltage is equal to I into R by Ohm's law. From this, resistance is equal to what? V by I. Substituting this resistance over here, we get sigma is equal to L in L by, instead of R it is V by I, so V into A, I comes in the numerator. So we are substituting for R, so this is the conductivity equation we got. Now we are substituting here for voltage. So we know that voltage is equal to work or energy by charge. So we are substituting over here sigma, instead of voltage we are substituting work by charge. So we get W is equal to work by charge. Charge will go in the numerator. So it is, so this is the equation. Now we know that work is equal to force into displacement and charge is equal to what? Charge is equal to I into T. This current into time. So substituting this in this equation of conductivity, we get L into I, instead of Q we substitute, that is I, that is can write in capital letter I into T, time T, divided by W, which is work is equal to force into displacement. So force into displacement into area. So now we get this area. We get this equation, that is sigma is equal to L into I into T by F into D into A. Now we can substitute for force. We know the equation for force. So force is equal to mass into acceleration. So we are substituting that over here. So L into I square into T by, instead of force we are substituting mass into acceleration into D into A. Okay. So now we have got the equation for conductivity like this. So using this we can find the dimension of conductivity using this equation. So we know that for L, so well, L in dimension length, its unit is meter, so it is represented by, meter is represented in dimension as capital letter L, so it is capital letter L. Then I square, which is current square, in dimension it is written as A square, its unit is ampere, so it is A square, current unit is ampere, so we get A square. Now T, it is in second, so we in dimension we are writing second as capital letter T, so it is T. Okay, then divided by, so mass into acceleration. We know that mass, it is represented in dimension as m. Now acceleration, we know that acceleration is equal to change in velocity by change in time, which is equal to, its unit is meter per second square. So meter in dimension, meter which is length, becomes what? We are representing it by capital L. Then second square, that is time, second square, it is written as T square. So dimension of A we get L by T square. Substituting that over here, we get, instead of A acceleration we are substituting its dimension, that is L. Then it is T square. T square goes into the numerator, and the remaining term is D and A. So D is what? It is displacement or distance. Its unit is meter. So again, meter, dimension is L. Then here it is area. Area unit is meter per, area unit is meter square. So meter square means again its unit is L square. its dimension is meter, its dimension is L, so we get meter square, so it is L square. So once again I'll say that is sigma. We have got the equation, final equation as L I square T by M, that is mass into acceleration into distance into area. So we are taking the dimensions of these terms. So L, it is in meter, its unit is meter, and in meter dimension it is represented by capital letter L. And I, which is current, so current, its unit is ampere, and dimension we are writing it as A, so it is I square, so here A square. Then T, which is what? T is what? It is time unit is second, and in dimension we are representing it by capital letter T. So here then mass is represented in a dimension as capital letter M, and acceleration, its unit is meter per second square, its dimension is L by T square. We are substituting that L by T square over here. Then this is D is displacement or distance, its unit is meter, so its dimension is L. Then area, its unit is meter square, so its dimension is L square. So this is what we get. So simplifying, we get sigma is equal to, so 1 L and L get cancelled. So here we get A square T cube by, in denominator we have M L cube. So we can write this as sigma is equal to M inverse, okay, L minus 3 A square T cube. So this is a dimension of the conductivity that we get. So this is how we find the dimension of a conductivity. So it's